The last thing I want to look at is using something called parameters. Um, what that allows us to do is make our module a little bit more flexible in that if we decide, oh shoot, this actually needs to be an 8-bit adder, uh, what we can do is if we design our own parameters, it should be really easy to adjust. So we're going to call this an n-bit adder using concatenation. And so what I want to do is put a parameter in here. That's just what we call a parameter, and that's kind of like a constant. And I'm going to say n, and we're just going to say that we now want this to be an 8-bit adder. So a bit width of adder. Now, what I can do here is I can go through and evaluate all my constants and see where I can put n in here. So that means A is an 8-bit number and B is an 8-bit number. So what I could do here is I can still say my minimum index is 0, but I can't have this 3 in there because this would make it a 4-bit. What I need to do is put n in there. And I need to look at this though. What is the width of this vector? I've got 8 to 0. That's a 9-bit vector, right? 8, 7, 6, 5, 4, 3, 2, 1, 0. The amount of numbers I just said was 9. So what I could do is just do n minus 1. And so that this math will kind of evaluate when you program the FPGA. So I'm going to do that same thing for the output as well. N minus 1, and that constrains it to an 8-bit vector. Cin and Cout can stay whatever size they currently are, which is 1 bit, because they are always going to be just single-bit variables. And as it turns out, I don't need to adjust anything here because there's no actual references to the indices at all.